I kind of wanted to tell you a little bit about what we're doing at Facebook with JavaScript and with React and kind of how we're thinking about it. I think a lot of the points and a lot of the issues that we face are probably relevant to this group. So next slide, thanks. Okay, so my group at Facebook is called Product Infrastructure. It's kind of a made-up thing. I don't know of a product infrastructure group at any other company. And our goal is to make product teams, to help product teams move faster, to be able to build solutions and iterate on them more quickly. And what we've done is build a lot of internal libraries and frameworks and tools. A number of these things have found their way into open source. And what we found is that the things that Facebook product teams need in order to move faster are the same thing product teams everywhere need to move faster. And the sort of flagship project for our group is React, which I gather a lot of you have heard about. We have this Flux architecture pattern that kind of goes with it. It's really teaching people about how to do functional programming and how to use immutable data, even to power a UI. And then we also have this framework for data fetching we call GraphQL. There's a bunch of other stuff my group builds. A bunch of it is in open source, and some of it isn't. We build UI libraries. We do a lot of work in C and C++ for Android and for iOS. I'll tell you a little more about that. And I think it's kind of funny that Facebook would even be invited to speak to people in finance, because I think we have this reputation of like playing fast and loose a little bit. And a lot of our rhetoric that you see is this sort of like kind of move fast and break things. That's actually really changed over the time that I've been at Facebook, which has been the last 6 years. And when you have 1 billion users, you kind of really don't want to break things. And there are a lot of businesses that really depend on us who also really don't want us to break things. So, I think, but what we have found is that the way you make products better is by iterating on them. It's not by sitting on them or designing them really well or anything like that. You really have to be able to ship them quickly. And I would, without knowing a lot about what you guys are doing in detail, I would still submit that, the way you guys can make your products better is by shipping them more quickly. And, the idea behind, what would you do if you weren't afraid is to make it so that it's harder to ship something that breaks things, but then if you do that, to make it easier to clean that up. And, web deployment is one great example of a way in which that's really changed what we can do with software, the speed at which we can build new things. And so this is really, in the end, when we talk about helping product teams move faster, this is really what we're talking about, which is improving iteration speed. And iteration speed happens at many levels. It happens at the level of a developer sitting in front of his or her computer making changes. It happens at the level of a team trying out a new feature, and then it happens at the level of shipping a new thing and trying it with customers. And I think JavaScript is like at the center of a lot of what my team does for this very reason, because JavaScript is this incredibly flexible tool and environment and ecosystem that really enables this kind of rapid experimentation. So I think it's worth asking the question, like, why has JavaScript emerged of all things? Why is JavaScript the place where so much of this innovation is happening, and where a framework like React, which is really just an idea. It's an idea about how to apply functional programming patterns to user interface. Why did that get developed in React initially? And why is so much of what we build that's new and interesting happening in JavaScript? And I think the answer to that question is actually sort of a tautology a little bit, which is that because there's already a ton of stuff in JavaScript. And the web browser is a fairly complete environment in which you can ship code. And if you've ever looked at NPM, as we all know, there are extensive NPM libraries for left padding a number. If you followed NPM Gate a couple weeks ago, but that as we can make fun of that, but it's actually kind of cool that you can find pretty much a library for anything. And before this talk, I looked, and there's like a ton of great libraries you can use for financial calculation, for formatting, that are all written in JavaScript. So that's probably the number one thing, but we'd have to ask how did JavaScript become ubiquitous? There must be some reason why that happened. And I think the next point I would make is that JavaScript is one of the few higher level languages that's always been embedded. It's always been like run on clients. And I think a lot of people really like Python, for instance, and look down at Python people, all look down at JavaScript like pretty much uniformly. But Python is they're not small engines for Python, and they're not multiple engines for Python, with some exceptions. JavaScript literally runs in refrigerators, in DVD players. It's kind of ridiculous, all the places that JavaScript has been run. So, and it's not that these other languages can't, it's just that this is the lineage of JavaScript, and this is why it's really relevant, especially today when so much of what people are doing with their computers is not necessarily on the desktop. It's also on mobile. It's also in their car and literally on their refrigerator, on their watch too. The next thing about JavaScript that is like defines what it is that it's always been interpreted or just-in-time compiled, and these things are kind of the same thing. And if you think about what you like about JavaScript, assuming you like some things about it, this is actually one of the first things that developers talk about, right? Like the difference between writing some code, hitting save, and then hitting reload, or running your tests really quickly in Node versus a minute, 2 minutes, and at Facebook we can talk about like 30 minutes or an hour of compile time. You get a lower quality product if developers really struggle to write and test their code. And so, again, like it's all about iteration speed, and this just-in-time compilation is key to that. And just-in-time compilation isn't just about the developer experience, it's also about release, right? So like the fact that you can ship something and then look at your metrics and realize that you shipped a bug and then ship it again right away is huge. That gives you confidence and it gives you power. And it also reduces the QA cycle. And I recognize that the sort of bars we're talking about for financial are different than they are for a consumer app like Facebook, but the principle is the same, which is that you can make more changes and test them more quickly because of this property of JavaScript. But I think the last thing about JavaScript is maybe the most important, which is that it's super expressive and relatively unopinionated about how to do anything. I mean, it wasn't until relatively recently that we could all agree on what a JavaScript class is. And even that is still, kind of murky at times. And, that's been a problem for JavaScript for sure. And, many frameworks ship with their own class definitions still because of this. But it also is why you see so many of these new ideas that get written in JavaScript. It's because you can write your own meta-object protocol in JavaScript. You can write your own mix-in framework. And especially you can experiment with functional ideas in JavaScript. And I think, I believe that software engineering in general is in its infancy. Like I don't think we know much about how to build big programs and make them work over a long period of time. And I think we're finding already that like some of our ideas, especially about object-oriented programming, are at best misguided and potentially completely wrong. And that I think we'll see like functional programming really take off as a way of thinking about structuring our programs, and JavaScript really lends itself to that. And there's a lot we need to build. We need to kind of go back to some first principles in order to and build them up again. And that's exactly what React is, right? Like, we were handed this idea that MVC and object-oriented programming was the way to build user interface. And we built React saying that, like, well, we'll work with that if we have to, but it's really not how developers want to think about user interface. So, I talked about all the great things about JavaScript, but there's a lot of problems with JavaScript. And, this is one that I think people point out a lot, right? And this isn't really about JavaScript's floating point support, like it's the same as every other language. But the issue is actually that I can't say that if I need a real number or certain precision, I can't express that easily in my program, and I can't prevent other developers from making errors that could be disastrous, right? Like those floating point errors are no joke, man. And we have them at Facebook too, and obviously we handle currency in a lot of the things we do. So lack of types in any large program is problematic. And I've listed 3 problems here that I just want to talk about quickly with JavaScript. Not ready yet, but But I think lack of types is the one where we're actually making progress. And this is something where, if you take away something from this talk that's actually actionable, there is something you can do about lack of types in JavaScript. And I encourage you to look at 2 projects. One is from Facebook. It's actually my group that works on it. It's called Flow. And the other is from Microsoft, and it's this project called Typescript. And both are about gradual typing for JavaScript. So the idea is that you can take a JavaScript program, and in places you can annotate it with types, and then you'll get told about errors when you call these library methods with the wrong types. As your program gets bigger, as your developer core gets bigger, this goes from being optional or nice to have to being absolutely necessary. It's been really powerful for us at Facebook. I really encourage you to look at this, and I think it's interesting to me that types really started about being correctness. It's about well, how should we interpret the data that's stored at this memory address? But even when you take that all away, you still want types because they're really valuable for structuring programs. So this is an area where it's a potential problem with JavaScript, but if you're willing to do a little extra work, you can make that go away, and I encourage you to do that. I'll go through increasingly more difficult problems to solve. Next one is that JavaScript is single-threaded, and this is this certainly causes a fair amount of FUD. I'm not sure how big a problem it is, but basically, if you have a slow-running JavaScript program, there's not a lot you can do about it except try to not do as much with it, right? Now, having said that, what we found in practice is that parallelism is very hard to write, to gain any benefits from, and then to preserve those benefits in production. So even in places where we've painstakingly optimized something to make it parallel at Facebook, when we go back and visit that a year and a half later, we find that we've done something that's made that basically given away all the gains that we got, and we've been paying this really high cost and complexity for parallelism. So I would emphasize concurrency over parallelism, and concurrency can be achieved in JavaScript. This is basically breaking your program up into small tasks that where you yield control back to some scheduler. So what you're trying to avoid is doing a bunch of work and then finding out that the user has moved on to some other task. And that sounds like, yeah, okay, but that happens a lot in our JavaScript programs, and what we found is actually by improving the concurrency of our programs, we can get a lot of these performance gains without having to resort to parallelism. That said, we still haven't really figured out how we're going to make web workers really work. And I know, some of the stuff that OpenFin does actually enables this. I think that's pretty interesting. I don't, the technologies I work on, we don't always have these options. This is still something that we're figuring out, but I'm fairly confident that we'll figure it out. Last one is the worst thing. And this is the hardest problem that I deal with JavaScript, especially since most of the users who come to the apps that we build expect it to just start right up. And Facebook's homepage delivers lots of JavaScript, more than we want. And all of that JavaScript has to be lexed and parsed before it can even be run at all, because there's a rule. You have to sort of show syntax errors before you can do anything else. And then there are very complicated optimizations in every JavaScript engine about when this code gets compiled and JITted and stuff like that we spent a lot of time trying to understand. At Facebook, we've built a fair amount of technology to try to improve our init time for JavaScript, but as a JavaScript program grows, this is by far the hardest thing to contend with. And I would say that if you don't have a problem with slow init time in your JavaScript yet, just wait. As your code base grows, it will get worse and worse. And I'm happy to talk about some of the things we're doing. I'm not going to go into the technical details here. I think it's really interesting, but of all the things, this is exactly the flip side of what we said we liked, right? Which is this just-in-time compilation piece. So it's not really fungible. We're going to have to invent some technology here to make this better. And that's something that we're working on really hard. I'm happy to talk to you about what we're doing with that. After that, I thought I'd give it up to Q&A. So any questions? After that, I thought I'd give it up to Q&A. So any questions? Yes. What are we doing? Okay, all right. So, let me describe that a little bit. So, basically, all of our apps at Facebook are divided up into modules. We use like an AMD-like pattern. And what we've done is we've written a static transformation that makes it so that you don't end up acquiring your module dependencies until you actually use them. So we call that lazy initialization. And that really helps cut down the amount of JavaScript you need to load. Although on the web, it's problematic, right? Because you can't intercept a call to load a module. You have to have all your JavaScript present, which means that all has to be lexed. We've tried everything. We've tried delivering it at strings and then evaling it. For React Native, we have the option of like actually putting hooks in the VM for this. Again, in React Native, we actually have implemented a bytecode cache so that we can remember the compiled version of our JavaScript. That's fairly effective. But it's only an option when you have control over the VM, and it's something that we're still working on. There's a lot of other really crazy things we talk about.
There's a trade-off against browser caching, too, if you're doing the kind of lazy loading of modules, right?
Absolutely, yeah. So, and you pay for transfer, to load all your JavaScript, and then you pay to, as I said, you pay to lex it. Just showing it to the VM incurs a cost, and then when you enter a function, that's when it gets compiled. So it can also be really hard to think about, like what's slow and where. Yes.
Can you talk a little bit about the scale that you're solving for? And,
Sure.
Some of the harder problems related to that scale?
Yeah, absolutely. I think the most interesting scale at Facebook is really the size of the developer core. So we have hundreds of developers who work on our React Native app and thousands of developers who work on our web app. Basically, there's no point at which we can dictate to developers that they have to build something a certain way because we know that doesn't scale. So really, the framework has to guide you down the right path. And I think that's maybe the most interesting thing about working at Facebook. I guess the sort of related point to that is that we kind of have this approach where product teams get to build whatever they want. If they want to take a new library or they feel like the most efficient way for them to do something is to incorporate some technology, the infrastructure teams almost never tell them not to do that. It's our job to kind of enable those use cases. So that creates a lot of pressure on the app. It means that our apps grow really quickly and our JavaScript grows really quickly. I don't have lines of code quotes ready for you, but it would appall you, I'm sure. I'll try to look that up while I'm sitting and get that to you later. Other questions? Yeah.
I wanted to ask what you think are the big benefits of using GraphQL. I know there's a lot of documentation and discovery stuff built in.
Yeah.
And coming from Facebook, you guys have thousands of devs, hundreds of projects. Discovery is a big thing.
Right.
So is that the big benefit? Are there other big benefits?
Sure. The question is about GraphQL, and if you haven't seen this is our proposal for an alternative to HTTP REST. The question is how should a smart client, whether it's written in JavaScript or not, talk to a server? And for now, the answer has been HTTP REST. And one thing that you definitely see is that this discoverability element, and we ship a really neat tool called Graphical. If you've seen GraphQL and you've never seen Graphical, it's like GraphIQL. You kind of won't get it until you see this tool, and then you're like, oh, I get it. This is pretty neat. But I don't think discoverability is the most important thing about GraphQL. I actually think the most important thing is that it shifts the power and the locus of control from the server and the people who develop the server to the client and the people who develop the client. So the main thing that I see when I look at HTTP REST is SQL. Basically all of the HTTP REST verbs match SQL verbs. And what you see in HTTP REST APIs is a server developer generally telling the clients here, call me this way to get the list, and then call me back to get these objects, and then call me again to get the details about these objects. What GraphQL allows is for the client developer to say, hey, this is the request I want to make, and it's got to have the list and the details all in one go, especially as we move to mobile where the cost of a round trip may be multiple seconds. You really can't afford to go back and forth to the server to fetch a list and then fetch details about that list. So that's how I think about GraphQL. Yeah, sure. Okay, why can't you use WebSockets in place of GraphQL, I assume you mean? Okay, sure. I think the main reason is that at Facebook in general, we're looking for like structure in our application. So you can, but you have to invent that, right? So you could certainly run GraphQL over sockets, and that would actually be fine. But you'd need some way of making a contract between the client and server that you'll be able to maintain. Yeah. Well, if you want to write GraphQL for WebSockets, I'll use it. That sounds really great. All right, I think I'm out of time, but I'd definitely love to chat. I'll be around later. Thanks.
Thank you so much, Adam.